Hello everyone. Today we'll be learning what's called the z-score, and this is very important in normal distribution and how you calculate with normal distribution. So let's just review very quickly what we did last time with normal distribution. So a normal distribution is in the shape of a bell curve where the mean is in the middle. And depending on how many standard deviations you move, you include a different percentage. So if you move one standard deviation on both sides, you're going to include 68% of the population. If you move two standard deviations, both sides, you're going to include 95% of the population. And if you move three standard deviations, you're going to include 99.7%. And depending on these percentages, you can kind of find what's the percentage or what's the probability that it's in between here and here, right? You can calculate that area right there using those percentages. But there are limitations to this method because you can't really calculate in between the standard deviations. So using the same mean and the standard deviation, let's say that the mean was 175. Standard deviation is 3 centimeters. So let's say that that would be 172, that would be 178. And let's say we want to find what is the probability that x is greater than 173. Well, that would be about right there. It's above 172, it's less than 175, and it's greater than 173. So we want to calculate this area right here. But we can't really calculate this area using these percentages because it doesn't land on the standard deviation, right? So we need to use a different method to calculate this kind of probability. And most of the time, it's going to be in between the standard deviations. Okay, so to calculate this kind of probability, I first need to introduce you to the standard normal distribution. And you can kind of think of this as the unit circle for normal distribution. So in unit circle, you find, or you use the unit circle to find the trigonometric function value, sine, cosine, and tangent. And you can basically apply the same thing to any circles and any right triangles. And you can kind of do the same thing with normal distribution. We are simplifying the normal distribution, just like you simplify the circle to a unit circle, so to make the calculation simpler. We're doing the same thing here with normal distribution. And a standard normal distribution would be a normal distribution where the mean is 0 and the standard deviation is 1. So each time you go to the left or to the right, you're moving by 1. And the area under the curve is basically the same for any normal distribution. So we're using this standard normal distribution and applying it to other non-standard normal distributions like these to find the area under the curve more easily. Okay, so for example, on the right here, standard normal distribution, probability that x is greater than, let's say, 1.2. So 1.2 is in between the standard deviations. It's like right there, and it's greater than 1.2. So we want to find that area right there. how do you find that area? Well, for standard normal distribution, what statisticians did is that they found the areas under the curve for even the sections between the standard deviations. And these standard deviations are actually what's called the z-score. So if we know the z-score, then we can also find the area under the curve. So for example, in this case, the z-score is 1.2. And we'll need to use a table to find the area under the curve for that z-score. So z-score is 1.2. Let's go over here and see what we have. So 1.2. So the whole number of the z-score is on this column right here. And the decimal are on this row right here. So 1.2, whole number 1, right? It's right here. And decimal 0.2 is going to be right here. So we're finding the column and the row where they meet. So 1.2 is right here. It's 0.885. And what the z-score table tells us, it says 0.885, right? So you should automatically think, oh, this is definitely not this area because this definitely has to be less than 50, right? But this is bigger than 50. So the z-score table tells us the area to the left from this z-score point. So it's actually telling us this area right here. So if you're finding the value for a z-score of 1.2, it's going to tell you the area to the left of that. So to get the area, the yellow area here, the area to the right, you just need to do 1 minus that. Okay, and that's going to be 0.115. So using the z-score, you can find the area under the curve. Let's try a few other examples. Probability that, let's actually use between 2 points here. So negative 0.5 and 0.7. Let's find the area between those two z-scores. So on the graph, that would be between here, negative 0.5 and 0.7, about right there. Oops. So it's going to be this area right here. So before we actually look at the table, let's see what we have to do. When we find the z-score for negative 0.5, negative 0.5, it's going to give you this area right here, right? It gives you the area to the left. And also when you find the z-score for 0.7, it's going to give you the whole area. So if you just want this, oops, I'll have to use this area right here. If you just want that area, what should you do to the two areas? Well, you'll have to do the orange area, right? Orange area is the whole thing minus the green area, right? Green area is that thing, and then you'll get the light blue area. Okay, so let's do that with the table. So 0.7 is going to be here, 0, and then 0.7 is right here. So it's going to be right there, 0.758. Okay, so that's 0.758. And how about negative 0.5? Negative 0.5, we'll have to look at the negative 0, not 0. Negative 0, and then 0.5 is right here. So negative 0.5 is 0.309. Okay, so the area under 0.7, or to the left of 0.7 is 0.758. Area to the left of negative 0.5 is 0.309. So to get the area in between that, we'll have to subtract them. Right, and then we're going to get 0.449. Okay, so the light blue area is going to be 0.449. So this is how you can use z-score to find the area under the curve. Now let's use the z-score to find, now this is a non-standard normal distribution because the mean is not 0 and the standard deviation is not 1, and in fact most data in the world, most continuous data in the world are going to be non-standard. So we'll need to find a way to apply the standard normal distribution to a non-standard normal distribution. And the way you do that is to find the z-score. Okay, so let's go back to that question right there. So probability that x is greater than 173. So that's the yellow area we're trying to find, right? This area. And let's find the z-score for that. We can't do 173 on the table because the table is just for standard normal distribution. So to find the z-score of a non-standard normal distribution, you'll have to do x minus the mean divided by the standard deviation. Okay, so in the case of this 173, that's going to be 173, you put that in for x, minus the mean is 175, divided by the standard deviation is 3. Okay, so that's going to be 0.67, about. That's 2/3. Or it's going to be negative 0.67. So it's negative 2/3. So let's look on the table and see what we get for negative 0.67. So it's going to be at negative 0.67. We only have one decimal point, so let's go with 0.7. Negative 0.7. So it's right there. 0.242. 0.242. So the area you get is 0.242, and we've actually used negative 0.7 for that, because there's only one decimal point on the table. So that means from this point, remember it tells you the area to the left. This area right here, the red area right here, is 0.242. So to get the yellow area, you'll just have to do 1 minus that. Okay, so that is going to equal 0.758. Okay, so now using the z-score, and this is the z-score, using the z-score, we are able to find area under the curve for even between the standard deviations. Okay, so that was between the standard deviation, but we were still able to find the area for that one. Okay, so that's how you can use z-scores to find the area under the curve of non-standard and standard normal distributions.